Hi, my name is Margaret. This is part 2 of the introduction to inheritance. At this point I want to talk a bit about the protected access modifier. Java has a number of different access modifiers. Public is the most accessible one. It allows anybody from any class to access your public members. Private is the total opposite. Private is the most restrictive access modifier. Only the class itself can access private members. If you declare a method without an access modifier, this is by default package private, which means a method that has no access modifier can be accessed from within their own class, and it can be accessed from within the own package. Now, the protected access modifier is somewhat similar to the default package private, but in addition to being available within the own class and within the own package, it is also available for all subclasses. So protected is an access modifier that is used only in connection with inheritance. Just to be clear, I want to point out that class members, like methods and fields, retain their original access modifier when they are inherited. That means if a subclass inherits a method and it used to be public in the superclass, it is still public in the subclass. If it used to be protected in a superclass, it is still protected in the subclass. If it used to be private in the superclass, it won't be accessible in the subclass. The protected access modifier can be useful to grant subclasses access to certain methods. However, fields should remain private as a rule of thumb. This will give you flexibility to change your internal implementation later without affecting other people's code. This will allow you control to validate input, also to expose the value of a field, let's say only for reading and not for writing. You could do that by having a getter but no setter. And then it helps you to protect the data integrity. If you keep your fields private, you prevent others from making unwanted modifications. At this point I want to talk a bit about subclass constructors. Just as a reminder, constructors are not inherited. The first task of a subclass constructor is to call the constructor of its direct superclass. This can be explicitly or implicitly done. If the superclass has a default or a no-argument constructor, Java can call it implicitly. Every class you declared so far, without specifying any inheritance relationship, automatically derived from object, which means whenever you declared a constructor in such a class, the very first task in this constructor was not to execute the first statement you specified, but to call the constructor of object, which is the constructor of the superclass. And only once the superclass has been successfully initialized, the constructor call could be completed. Now, if the superclass does not have a default or no argument constructor, then the superclass constructor needs to be called explicitly as the very first statement of the subclass constructor. If the superclass does not have a default or no argument constructor, that implies that the only constructors available are all parameterized. That implies that no matter which constructor we would choose to call, we always need an argument. And Java does not know which arguments to fill in for us. So it cannot call those constructors implicitly. It is the responsibility of the software developer to call the superclass constructor explicitly with the right amount and type of arguments if no default or no argument constructor exists. This is how a superclass constructor call looks like. You use the keyword super followed by the argument list. Now what is inside the argument list depends on the parameters specified. The arguments passed always have to match number and type of the parameters. So important thing to notice is the keyword super. Typically we call a constructor by the class name, but not in this particular situation. When you call the constructor of your superclass, you use the keyword super. Instantiating a subclass object triggers a chain of constructor calls. The last constructor called is the constructor of the class object, the root of the inheritance hierarchy. The body of the original subclass constructor finishes last. So let's look at an example. Let's say we are calling the constructor of class letDog. This is a class we introduced in the Inheritance Part 1 slides. Now letDog constructor calls as the very first task the dog constructor, because dog is the superclass from letDog. Now dog constructor calls as the very first task the object constructor. At this point the object finishes whatever statements it has to do in its constructor. When object constructor is completed, the control returns to the dog constructor. Now the dog constructor can finish whatever statements need to be completed, and the control is returned to the letDog constructor. Now this letDog constructor is the original subclass constructor, and that finishes last. So now the rest of the instructions in this letDog constructor are executed, and this letDog object is initialized. At this point I want to talk a bit about overriding methods. Always use the annotation override when you modify an inherited method in a derived class. There are two significant advantages of doing so. One is it helps you catch errors. If you accidentally misspell a name, or if you have an incorrect parameter list, the compiler will let you know. Besides catching errors, it also has the advantage of making your code more clear. By declaring your intent with the override annotation, every programmer that works on your code can see immediately what you try to do, and that makes your code more clear and easier to read and maintain. We saw already how the keyword super can be used to invoke the superclass constructor. It can also be used to invoke a method implementation of the superclass. When a subclass method overrides an inherited superclass method, the superclass method can be accessed by preceding the superclass method name with the keyword super and a dot operator. So here is an example. I try to override the toString method, which is declared in object, and I want to use the original toString implementation plus something else. So whatever change was intended should go here. By the way, do not override a method by only returning the superclass implementation. If this is your intent, if all you want is the implementation of the superclass, there is no need for overriding. Only override if you actually make a change. So here you can see the method call from your superclass, super.toString. Now here is a caveat. When you attempt to call the superclass implementation without the keyword super, this can easily result in an infinite loop. So here, once again, you see the toString method with the keyword override. The problem here is that I'm calling toString without the super dot operator. I might intend to call the method from the super class, but in reality, I call this very toString method from my own class, which means I am in a recursion. I'm calling myself over and over and over again. This is a recursion without a base case, which means I fill up the stack until I have a stack overflow. And this is something you want to avoid. You might remember that binary operators in Java need the same type on both sides. My left hand side is of type dog, my right hand side is of type sled dog. But because every dog is a sled dog, Java can perform this conversion implicitly. Same is true if I would have, for example, airplane and a jet. Every jet is an airplane. So even though my new instance is of type jet and my variable is of type airplane, there is no problem. Java can convert a jet and then assign it to my airplane. If I use the variable my dog, I can only access the members from my dog. I cannot access the operation pull sled. That is true even though my dog is instantiated with an actual sled dog. As long as my variable is of type dog, the sled dog functionality is not available. Now at one point I might realize that I really want to call the method pull sled. One thing I can do is I can convert my dog back to a sled dog. However, Java is not going to do that for me anymore. Not every dog is a sled dog. If I try to assign my dog to my sled dog, I will get a compile time error. However, I can specify it explicitly with a cast. So I can say, I am convinced my dog is a sled dog. The compiler trusts. The runtime checks. By using the cast, I let the compiler know that I am sure my dog is a sled dog. So the right hand side gets converted to a sled dog, the left hand side is a sled dog, and the assignment can be performed. Similar things happen here with airplane and jet. Not every airplane is a jet, so Java won't perform the conversion for me. However, I can do it explicitly. I can use a cast, and by doing so I let the compiler and other developers know that I am convinced my airplane is actually a jet. It should be converted and assigned. This will compile. However, at runtime it will be checked, and if I was wrong and my airplane is not a jet or my dog is not a sled dog, then I will get an exception. Sometimes we just know that my dog is a sled dog. Sometimes we might receive data or input from external sources and we are not that sure. Java provides an operator called instance of. The instance of operator tests whether a particular object is an instance of a given type. So here I can use it, for example, to check if object instance of dog. This expression is true if and only if my object happens to be an instance of dog. If that is the case, I can safely cast my object and assign it to my dog variable. One last guideline regarding inheritance. When you identify classes for your application and you realize that a number of classes are closely related, factor out the shared fields and methods in a superclass. Then use inheritance to reuse the code from the superclass in your subclass.